Okay, hello everyone. I'm Philip from Supermicro GPU System team. So today I would like to introduce our new generation Intel Sapphire Rapids platform GPU server. So first, looking at AI market trend, the total value from the AI is estimated to $1.6 trillion by 2030, and the Asia market increased 37% from 2023 to 2030. And the AI is adopted in many industries, including healthcare, manufacturing, and the media. One of the well-known use cases is ChatGPT. As you can see that the ChatGPT reached first 1 million users in only 5 days, and reached first 100 million users in only 60 days. So this kind of a large language model drives a huge demand on content generation, voice assistance, and the language translation. So GPU server provide a very important role in this kind of application demand. For example, the GPT-3 with 175 billion parameters, and it has 333 data flow data need to be trained, and it also needs huge amount of the computing power for inference. Supermicro is a leading AI and HPC GPU server provider. We understand differently from each field, from edge to cloud, as well as from training to inference, because we have many GPU server design experience from 2008. And we designed one U4 GPU optimized server in 2015. And we released first SM-type GPU server in 2017. In 2021, we announced the innovative building block concept, Universal GPU. This year, we will announce Intel Sapphire Rapids GPU platform in Universal GPU and the other GPU architecture. So GPU is typically used in HPC, rendering, and the AI training and inference. But each field has different requirements. For HPC, it needs high accuracy on floating point computing and high node-to-node communication by InfiniBand. For rendering, it needs high memory capacity to shorten rendering time and the CPU cores for virtual workstation. For AI training, it has similar requirement with HPC. But for inference, it needs to scale out and to do different workload in each side. Today, let me introduce our new generation Intel Sapphire Rapids platform GPU server. We understand differently in each AI and HPC workload. So we designed wide variety of GPU server with different architecture that strengthen the data speed from CPU to GPU, as well as from GPU to GPU. In this page, I would like to go through the very high-level GPU system information and then dig out more detail in the following page. So for the large-scale AI training, HPC, and data processing, such as deep learning training and scientific research, we basically released 2 system models. The first one is our AU with NVIDIA HGX H100 GPU model, or Intel PVC GPU module. In the system, all GPU is interconnected by NVLink switch, so it provides 900 GB per second bandwidth. It's around 7 times than PCI Gen 5. The other one is our 4U Universal GPU. with the NVIDIA HGX H100 GPU module. For the PCI type GPU optimized server, we developed two architectures on our 4U system. First one is dual root with PCI switch. The other one is direct attach without PCI switch. We also have a 4U 4 GPU air cooling workstation and the 5U liquid cooling workstation. And the system is shown outside. So this PCI type GPU server, user can install H100 or Intel best 1100 GPU card for medium-scale AI training or inference, or L40 for cloud rendering, or L4 for inference in edge side. So for large-scale AI training, data processing, huge amount of data need to be trained and processed. So it needs to optimize GPU to GPU performance by NVLink design. And it also needs GPU direct RDMA for node-to-node communication and the GPU direct storage to transfer data from GPU memory to the storage device. So we basically have two systems. The first one is AU with 8 NVIDIA HGX H100 GPU module or Intel PVC GPU module. The system can support up to 12 PCI for infinite band or networking card to node-to-node communication. It also supports up to 16 NVMe SSD for GPU direct storage. The other one is our 4U universal GPU system with NVIDIA HGX H100 GPU module. These two systems designed with a PCI switch. Each PCI switch connects to PCI slot and the GPU module and the NVMe SSD to enable GPU direct RDMA or GPU direct storage. For the medium-scale AI training, HPC, graphic, or edge computing, we suggest to use our PCI type optimized GPU server. So we designed the two architectures in our 4U system. The first one is dual root with PCI switch. So the PCI GPU card communication with a PCI switch without going to the CPU. The system we suggest for the AI training because it has less dependence on the CPU processing. The system can support up to 10 double width GPU card. And we also have 5U option with a better thermal design. It can support 10 350-watt GPU on the 35 degrees Celsius. The other architecture is direct attach without PCI switch. So it reduces the latency between CPU and GPU. And the system without a PCI switch can support up to 8 GPU cards. And it has more cost efficiency than the system without PCI switch. We also have the 4U 4 GPU workstation. So in the following page, I would like to share our successful story. The first one is our Intel F13 Datacenter system. The customer is United States Tier 1 GPU cloud provider, and they deliver their massive GPU resource on top of their cloud architecture. And the customer needs the Datacenter system as soon as possible because it has the 7 times in HPC, 9 times in AI training, and 13 times in AI inference than their previous A100. So we work closely with this customer in very early stage, and we deliver this system to our customer on time. So we already get thousands of the order from this customer in the United States. The system also used in the messaging app recommendation model training in Asia. This Asian customer use the system to train their recommendation model by using the user purchasing and browsing history and to show the attractive photo on the app to redirect them to the online shop. The system also used in the online food delivery service model training to send the appropriate advertising and the coupon to enhance their customer experience in Asia as well. So these two use cases is all about e-commerce. As you can see the bar chart in your right-hand side, the e-commerce market keeps increasing, and Asia occupies 42% market share in the world. The first one is Shopee. So this kind of e-commerce company need many AI-powered systems to train their model to provide a better customer experience in their user. So in the following page, I would like to share our NVIDIA certified system and the MLPerf benchmark test result. Supermicro is an NVIDIA certified partner, and we have done the most NVIDIA certified system than other server provider. The NVIDIA certified system is tested with a complete set of accessory workload with NVIDIA GPU and a networking card, and evaluated by NVIDIA. For example, for AI training, it uses the TensorFlow and the PyTorch. For inference, use the Triton, TensorRT, and the Triton, and also test multi-node for the networking and the security. So the NVIDIA certified system is proven to provide predictable performance on AI, HPC, and the data processing. There are many NVIDIA certified system categories, and our server system is focused on the most complicated data center for compute only or compute with graphic. This is our overall NVIDIA certified system list. For our new generation system, we already done the NV Core with H100, L40, and L4. For our previous generation, we got lots of the NVIDIA certified system certificate with A100, A40, A30, A16 in different segments. About the machine learning benchmark, one of the well-known benchmark tool is MLPerf from ML Common. The MLPerf consists of the 6 tests, including image classification, object detection, medical image, speed to test, NLP, and a recommendation. And each test uses different model to train and the inference. So this is our Intel A13 Delta NAS and the Redstone NAS MLPerf training result. Supermicro is the leading AI and HPC GPU server provider. So we know how to optimize our GPU server. So the result is training time in minutes. So lower training time means higher performance. As you can see that we have the better training performance than NVIDIA DGX H100. The score is lower means we have a better performance in training time. This is the MLPerf inference test result. As you can see that our 4U4 GPU have very outstanding inference test result than other server provider. Our 4U GPU have the similar test result with other server provider. So previous page is training. This page is for inference. Yeah. So finally, I would like to introduce our liquid cooling GPU solution. So why need liquid cooling? There are main two reasons. The first one is surging thermal design power requirement. Let's take Intel CPU for example. The CPU TDP is only 205 watt in per platform, but it increased to 350 watt in current EagleStream platform. And then the CPU TDP is getting more higher to the Birdstream platform in the next generation. It's around 500 watt. The NVIDIA GPU requires more power. For the previous A100 GPU module is 400 watt. The current H100 GPU module is 700 watt. So higher CPU and the GPU TDP challenging the current air cooling thermal design solution. That's why you can see many 1U, 2U, or high-density systems have some thermal limitation on the higher CPU TDP support. So the future of the CPU and GPU generation is likely to have the liquid cooling as current air cooling capacity is it. The other reason is the IT server power and the cooling power occupy around 90% of the data center energy allocation. So reduce the IT server power and the cooling power is a key to save power and your electricity bill. There are many ways to decrease IT server power. For example, to use titanium level power supply, use a multi-node system because it shares the fan and the power. And it also can implement the liquid cooling server. And how to reduce the cooling power? I think the best way is to phase in the liquid cooling server, and the server can operate in a higher operating temperature. So basically, changing from the air cooling to liquid cooling can save around 40% on the operating expense. So this is the two main reasons why we need to use the liquid cooling solution for our server. We offer three kinds of liquid cooling solution. First one is cold plate cooling. The second one is immersion cooling. The final one is a real door heat exchanger. So Supermicro overall can provide these three kinds of liquid cooling solution to our customer. This page is a PUE and the support density per rack for different cooling solution. As you can see, the real door heat exchanger PUE is around 1.3, but it's not sufficient PUE gain from the air cooling. The best value efficiency liquid cooling is cold plate. It's around 1.2 PUE. And the most power efficiency is immersion cooling. Today, I would like to focus on the best efficient cold plate liquid cooling solution in my presentation. So this is Supermicro cold plate liquid cooling solution. The heat dissipation from the left to the right. So the heat is dissipated from the server to the CDU. It is a coolant distribution unit in the rack. And then to the chiller, and finally the heat will be dissipated to outside by the cooling tower. So in your left-hand side, it is an internal loop between chip to the CDU. So Supermicro designed the CPU and the GPU cold plate, including the Delta NAS and the Redstone NAS. The rack can mount up to 4 Delta NAS liquid cooling server and connect to the CDU by the CDM. In your right-hand side, it is external loop between CDU and the cooling tower. And the cooling tower is also designed by the Supermicro. So Supermicro provides the overall cold plate cooling solution from the cold plate, rack mount, CDU, and the cooling tower. We also offer the one-stop shop for our customer for this kind of liquid cooling solution. This page is the cold plate liquid cooling rack level in the detail. So the heat dissipated from 1 to 5 in order. The first one is the liquid cooling server. So there are CPU and GPU with cold plate. And the liquid cooling server connects to the CDN. We call the coolant distribution manifold by the tube. And both tube and the CDN with a quick dry connector. So there is no leakage risk during connection. And then the CDN connects to the CDU by the hose. There is a 180 kilowatt CDU on the bottom of the rack. And the CDU also designed by the Supermicro. This is our Supermicro designed CDU. It's a cooling distribution unit. And the CDU with the 1+1 redundant, hot-swappable power supply and the bump. And it also has the touch panel and the networking connector to do the control in local or remotely. This is our CDU feature. As you can see that it can do the status monitor, alert, and the networking setting. So the CDU can see the bump and the liquid level detection and the temperature control and the pressure and the leakage and the flow rate monitor. So as I explained in the previous page, our CDU is 1+1 bump. So we have a video to show you how it works. So this is hot-swappable, and it has a touch panel to see it's still working because it's redundant. So it is very easy to upgrade with a painless because we have a hot-swappable bump to do the upgrade and the repair. And this page is to show you how to change the power supply. As you see, one power supply pull out and the system still working because it is hot-swappable and redundant. Our cold plate liquid cooling solution is a whole rack delivery. So it's very easy for install. User only need to connect to the facility water in their data center. It's very easy to installation, only connect to the facility water because we have a whole rack delivery. And the Supermicro is the first server provider to provide the Datacenter, the HGX H100 GPU liquid cooling solution in the world. And this good news was reported in many media in ISC 2023 this year. So besides the Datacenter liquid cooling solution, we also have a liquid cooling solution for Redstone NAS and our 4U8 GPU system in the rack level. Our corporate liquid cooling solution was integrated assembly and testing in our production. So we would like to provide one-stop shop plug-and-play liquid solution. So it is in our factory, we have the facility to test the liquid cooling recommend label. So besides the open-loop liquid cooling, today I would like to introduce our first closed-loop liquid cooling workstation 751G DHT. And we are aware of many scientific research, financial facilities, they need AI to enhance their competitive. So they need the workstation at the workplace where people working at. So the office friendly is the key concept for this system design. The system has the closed loop liquid cooling solution for CPU and memory and up to 4 GPU. And it can provide a very whisper quiet noise at idle. It's around 30 dB. And it doesn't need any data center level power or thermal solution. So it is a plug and play. It's very easy to install and it's very movable. Yeah. The system also win the Sheu 2023 this year award. This is overall the system spec. The system can support up to 2 350-watt CPU and 16 128 GB memory and up to 4 A100 GPU liquid cooling card. The system also recommendable can be a centralized GPU for the enterprise. This is an acoustic comparison between air cooling system and the liquid cooling system. As you can see that the noise level is very outstanding in our liquid cooling system. In the idle mode, it's around 30 dB. In the 50 loading, it's around 50 dB. In 100 loading, it's around 50 dB. So as you can see that the liquid cooling workstation has very outstanding noise level compared to the air cooling system. So finally, I would like to recap my speaking. Supermicro is a leading GPU server provider. We design a wide variety of GPU server to cover from the cloud to edge, as well as from inference to the training, to fulfill the every data span in this kind of the computing resource. So this is my overall presentation today. Thank you very much.